Okay. So this next day in geometry, we're going to talk about a figure that we haven't spoken much about, and that is a sphere. And in our packet, we are looking at our notes on page 12 in our packet. So if you want to turn to page 12, also pause and get yourself a calculator so that you can follow along. Remember that math is not a spectator sport, so you need to grab a pencil and you need to be writing down things and taking notes just like we're in class. That's the only way that we're going to learn it, okay? Is if we actually do it. So you want your calculator out and your packet and go ahead and turn to page 12 and fill in notes with me today. All right. So, first of all, the sphere has different parts. Okay. A sphere is like a ball. So, anything that's like a ball or a globe or anything that's round like that is a sphere. And a sphere is a solid where each point is equidistant from a center. So no matter where we are on the edge of the sphere, on the surface of the ball, we are equidistant from the center of the sphere. Okay, so let's just label the parts of the sphere. The first one, a diameter, is this line right here that goes all the way from one end to the other. It goes through the center. So it's very much like a diameter of a circle. A radius is this little distance right here between the edge of the sphere to the center. So we already know that a radius is half a diameter. Okay, so this point right here in the middle is obviously called the center. And the last thing we need to mention is something called the great circle. And the great circle is this circle right here that goes around the edge of the sphere. That is on the dotted line in the figure. And it divides the sphere exactly in half. So the great circle is through the very center of the circle, and it's the circle that divides the sphere in half. So if I were to slice my sphere, the great circle is the largest circle in the middle. Because if you notice, I don't know if I can draw this or not, if I were to slice it in other places, the rings would get smaller and smaller as I get closer to the edges. So the great circle is the circle that's the largest circle, which would go through the very center of the sphere if I were to slice it. All right. So let's talk about volume and surface area of the sphere. So this little thing down here in this box right here is very important. Now the volume has its own formula, and so does surface area. Remember, volume is how much our sphere can contain. If we're filling up that sphere with air or water or something like that, the volume is how much it would hold. So the volume of a sphere is 4/3 times pi r cubed. Now it makes sense that it has an r cubed in it because cubic units are the units that we use to describe volume. So it makes sense that the r is cubed in a volume. So 4/3 pi r cubed. On number 1, they gave us a radius instead of a diameter. So make sure if they give you a diameter, you take half of that to get your radius. And other than that, we have everything we need to know for this formula. That's all you need is the radius. 4/3 is actually just part of the formula. So 4/3 times pi times 7 cubed. Now, order of operations would have us do that exponent first. So 7 raised to the 3rd power, I can use my calculator correctly, is 343. So volume equals 4/3 times pi times 343. So I'm going to use my calculator and hit 4 divided by 3 in parentheses times 343 and then times pi. And again, if you don't have a pi key on your calculator, you can use 3.14 since we're going to have to round anyway. And when I round, I get 1,436. I don't know what's getting deleted here. 1,436.8. And this is volume, so it's going to be cubic inches. So that's the volume of my sphere. Okay. Number 3, we're going to skip down, and it says to find the surface area of the sphere. And the formula for surface area is 4 times pi r squared. So it's using that area of a circle there, pi r squared. And again, they did give me the radius, which is 2.8. So my surface area is going to be 4 times pi times 2.8 squared. So order of operation tells me I need to square my 2.8 first. And I'm getting 7.84 when I do that. So my surface area is 4 times pi times 7.84. So I'm going to use my calculator. And I'm going to type in 7.84 times 4 times pi. And I'm getting the surface area is approximately 98.5. And this is surface area. So remember, surface area is squared units. So square meters is my surface area of a sphere. All right. So we have done one of each, a volume and a surface area of the square of a sphere. Remember, if they give you a diameter instead of a radius, that you take half of your diameter to get your radius. Now let's talk about a hemisphere. A hemisphere is half a sphere. So if we were to take a sphere and slice it along that great circle through the very center of the sphere, then we get something called a hemisphere. And I know you've heard about a hemisphere when you talked about social studies and geography when you were in elementary school and junior high and all that good stuff. So a hemisphere is half of a sphere. And so they have their own formulas for volume and surface area. So let's just do number 5 together, please. Number 5 says to find the volume of the hemisphere. So if I look over to the side and over here, I'm still on page 12. I'm at the bottom of page 12. The volume is 2/3 times pi r cubed. 2/3 times pi r cubed. Now the volume of a whole entire sphere is 4/3 times pi r cubed. So it makes sense because 2/3 is actually half of 4/3. So that actually makes sense that the volume will be half of what the volume of a sphere is. So that's where they got that. So make sure I have my pen going. All I need is the radius, and I have that. My radius is 5. So my volume for my hemisphere is going to be 2/3 times pi times 5 cubed. Well, 5 cubed is 125. 2/3 times pi times 125. And I'm going to use my calculator to help me out. You can participate with me, please. So I'm going to hit 2/3 times 125 and then times pi. And again, you can use 3.14 if your calculator does not have a pi button. And that's going to round to approximately 261.8. Now this is volume, so I'm going to make sure I use kilometers cubed. All right, so that is the volume of a hemisphere. And I'm only going to do one more example just to try to keep this video short. I know the last one was kind of long. So the last thing I want to do with you guys is the surface area of a hemisphere. So I'm going to go down to problem number, well, heck, let's do number 8 because we haven't done one yet. So I said I was going to do number 7. Actually, let's do number 8 because we haven't done one yet that gave us a diameter. So I brought my equation down here for surface area of a sphere just because I didn't have it written on that page. So I'm on page 13 now, and I'm going to do number 8. And the directions say to find the surface area of the hemisphere. So I have a half a sphere, and I'm going to find the surface area. So the surface area is 3 pi r squared. Well, on number 8, they didn't give me a pi, or they didn't give me a radius. They gave me a diameter of 12.2. So remember, to get the radius, if they give us a diameter, you take 12.2 and divide it by 2, which gets us 6.1. So for R, I'm going to use 6.1. So my surface area is going to be 3 times pi times 6.1 squared. Now, order of operation tells me I need to square 6.1 first. So 6.1 squared, I'm getting that is 37.21. So I'm going to do 3 times 37.21 times 5. And I mistyped that, so I'm going to do that again. 3 times 37.21 times pi. And I'm going to round that, so I'm going to use my little approximately symbol. 350, and that's going to round to 0.7. And this is surface area, and remember, area has square units, so that's going to be square centimeters. So I've done one of each of you of surface area of a sphere, volume of a sphere, surface area of a hemisphere, and volume of a hemisphere. So hopefully that'll help you do your practice.